Hey everyone, welcome back to another episode of Solidity Fridays. Today I'm joined by my friend Stent, and we'll be looking at Chainlink. Hey Stent, how are you doing?
Hey, Tamara. All right, thank you. How are you doing today?
Yeah, very
Happy
well,
Friday,
thanks.
by the way. Happy
Yeah,
Friday
thanks.
to everyone.
Love a good Friday. Do
Cool.
you want to just explain what Chainlink is in case someone doesn't know?
Yeah, for sure. Maybe just before that, I just do a quick intro. Yeah, hi, I'm Stent. I work with a company called Float Capital. It's a bunch of South African people, actually, living mostly in Cape Town and a couple in Europe. And we building a DeFi product, so on Ethereum, and we actually use Chainlink. So I have done the analysis on the Chainlink smart contracts because we needed to know some information, and I'm just going to kind of use that same or do that same analysis again today. Yeah.
Awesome, looking forward to
Um,
it.
so let's kick it off. Basically, Chainlink is quite a big company. They're huge. I mean, maybe one of the biggest in the crypto space. And they have a few products, but the first thing that they ever did, which I still think is their main and biggest product, are Oracle price feeds. And a quick explanation on what an Oracle price feed is: it's just data from off chain getting on chain. And anyone can put data on chain, of course, but the idea is to put data on chain in a decentralized way, a decentralized and reliable way. And that's what Chainlink cracked. In fact, they weren't the first to do it. So Maker had to create their own data feed for US dollar Ethereum
Oh
or
yes, the guy.
USD. Yeah, and in fact, they just released that publicly, but Chainlink wasn't around back then, and so they created their own Oracle.
Oh wow.
Yeah, and they've now just released. I can't remember what the product is that they've released, but they've released that as now a product that anyone can use. And the Chainlink like architecture is quite complicated. I don't know it very well. So when I talk about architecture, I mean their network. So like each data feed has a bunch of nodes, no, like the same as how a blockchain has a bunch of nodes. And the nodes collect data, and then they have a consensus um, amongst each other about what the correct next data point is going to be, and then they post that on chain. I mean, technically, they actually do all of that on chain. So each node posts something on chain, and then they take the median. So the data, but we'll get into the details of that shortly when we look at the smart contracts. But this is the general idea. And I don't want to get into the architecture of Chainlink, their network, I mean, mostly because I don't really know it. And also because I think it's quite a rabbit hole, and let's rather
Mm.
stick to Solidity for now.
Yeah, I
Yeah.
think that's a good idea. Thanks.
Yeah. So anyway, that's a little something about Chainlink. If there are any questions about that, feel free to ask away. Otherwise, just assume that there are a few people here who know how Chainlink works. And this over here is the Chainlink website, and you can basically get some details on all the prices, the price feeds that they have to offer. You can see there's quite a few. This is not actually all of them. I don't know how the pagination is working, but it doesn't seem to be working very well. How do I go to the next page? Like, for example, I don't see ZAR in here,
Yeah,
but
we
let's
just checked.
search.
There is a round coin.
There is a
Yeah,
ZAR. There
around
it is over
the
there.
SAR USD on Polygon.
Yeah. Oh, maybe something else we should just say quickly. If we take a look at the Chainlink data feed without even looking at the contracts, it's important to know that there are these specific like values that each data feed has. There's the deviation threshold, and then there is the heartbeat.
Mm.
This is a countdown timer. The heartbeat is a length of time, and the deviation threshold is a percentage. And what these two numbers are trying to tell you is something about how the price updates. So on chain, you have like a set of data. Well, I'm just going to talk about prices because Chainlink actually don't post other off-chain data on chain. They're just dealing with prices, price feeds. So when I say data. I should actually just talk about price feeds. So I'm going to talk about price feeds from now on. So basically, each price feed has a history, right? You see these classic graphs. I mean, everyone's been on CoinGecko, and you like take a look at Ethereum for the past, whatever, 6 months or 1 year, depending on how sad or happy you're feeling at the particular point in time. And this is not a continuous line, right? It's a whole bunch of individual data points, and on chain, those data points are stored in a smart contract. And basically, the distance between it, which would be in time, the distance between data points is kind of what these two numbers are trying to give information about. So the deviation threshold says that there's not going to be a difference in terms of price of greater than 3% between consecutive price data points. And the heartbeat is saying there's not going to be a distance greater than in time, in this case, 24 hours. So it's not very obvious. I mean, it's pretty obvious once you see the last update plus the heartbeat countdown timer, but I don't know why they don't just say 24 hours. Anyway, so this ZAR USD is going to have a heartbeat of 24 hours. And what's also interesting is Chainlink promised this, but they don't actually keep to their promises. Man, I should have actually pulled this. Yeah, I'm not going to try search for that now while I'm on the call. But there's very interesting data that we found where Chainlink, like if they, like for example, the ETH USD price feed on Ethereum has a 27-second heartbeat. Let's actually just go to that one quickly.
Wow, that's so fast.
Yeah, it's wait, I think it was Polygon. Sorry, it's on Polygon that it has this 27-second. Yeah, there we go. So you can see it's 27-second heartbeat and a very low deviation threshold. No, it's not zero. It's going to be like some decimal. But we found that even there are differences of up to 180 seconds between price feeds. So, which is like 3 or 4 times greater than the heartbeat. So even though they say this stuff, it's not something you should just go and believe blindly. And the deviation threshold has similar differences where, they claim, okay, in this case, they're claiming 0, but it just must be a website problem,
Yeah,
front-end devs. Yeah, the front-end devs are maybe slacking a bit there. But if they claim like a 0.1% deviation threshold, you might even get up to 4%, like in extreme cases, like the 99.9% percentile. So even though they promise these, they do not fulfill them 100%. It's like
what they're aiming for.
Yeah, exactly. Anyway, so
and then Chainlink also has a verifiable random function, which is just an off-chain randomizer that brings those numbers onto chain.
Yeah,
we can look at that later.
Very
maybe.
Cool. Yeah, possibly. I have no idea about how that works, but you do, so maybe you can.
Yeah, or we could even do a part 2 if we don't get to it today.
Yeah, I'd love to know a little bit about that. But they do have a bunch of products, Chainlink. They did start off with price data feeds, and then they have this verifiable randomness, and then they have some other products that I don't know a single thing about, so I'm not even going to try explain them. I'm just going to butcher it. Anyway, so let's maybe climb into some code.
Yeah, that would be great.
Yeah, basically you could start off even here, I think. So here they offer, wait, where did I see it? There we go. So here they do offer the smart contract address, but I've already got some links open here. So I'm going to go from this point over here. And I just picked the first one on the list, actually. So I have no interest in 1-inch ETH, and I don't think it's the best one to pick, but the contracts are all the same in the end. So I just chose this one. And if we go this one here, yeah, 728, okay. So I'm sure you guys know about Tenderly, but this is my favorite way of looking at code on the blockchain. If it's not verified, if the smart contracts are not verified, unfortunately, Tenderly doesn't have such a nice view, especially when it comes to like debugging transactions, but in general, most companies or most smart contracts that are part of big companies or big protocols are verified. So Tenderly is great for looking at code, and as we will see, is more reliable than GitHub. When I say reliable, I don't mean their uptime. I mean the code on the blockchain is what is being run. The code on GitHub might not necessarily be that. So I generally I prefer to trust Tenderly and go have a look at the code here rather than on GitHub. So anyway.
Yeah, that's awesome. I should start using Tenderly. You've sold it. Thank you.
Yeah. And Tenderly, yeah, maybe let's not get into Tenderly, but it does a bunch of things. You can search for transactions and you can search for smart contracts, and it has a debugger and everything. It's really great.
Oh, cool.
And it's on like all chains. Yeah, it's really, really cool tool. Okay, so let's have a look here. I think so when you have a look, I'm not so sure if you guys have seen, if you're on Etherscan or whatever, and you go have a look at a contract. I mean, we can actually just do that right now, right? I'm not sure what it's not going to tell me what. Oh, Ethereum mainnet. Okay, so let's go. No, that's not what I wanted. I'm going to just quickly go have a look at this contract on Etherscan so we can see what it looks like there, because Etherscan is just kind of the default, right? So if you have a look at the contract here, I mean, like, also that it's not the best user experience, like developer experience in terms of reading the code, but you can see that they have the code here. So you can also just go have a look at it on Etherscan, or if you have Jedi powers, you can just go read the contract creation code.
Of course.
Yeah, this is something that I almost have right. I would do the video in Hex, but I'm just not quite there yet. I'm close though. Next video I'll do in Hex. Anyway, so you can see the code over here, but I prefer using Tenderly. And also, when you have a look at a contract, it's not just when you have a look at an address, contract address in Etherscan, it's not just a single contract. It's got the entire hierarchy inside the source code. So when you deploy Solidity, I'm sure as most know, you deploy the entire hierarchy together as one piece of code. And so that's why you will see, like, if you're using Open Zeppelin contracts and whatever, when you go have a look and you deploy, when you go have a look at your code on Etherscan, you will see, like, you'll have the Open Zeppelin contracts fully included, fully coded out. Yeah. Anyway,
which is nice sometimes to see that, but at the same time, it's not really what you're looking for. So often when I look at something on Etherscan and I have to scroll through all these contracts to get to the very bottom to see the contract I was looking for.
Yeah, exactly. It becomes a bit of like a nuisance. You have to look through this whole thing. You're like, oh, where is the contract I'm looking for? Yeah, it does become a bit of a nuisance, but that's how it is, I guess. Anyway, so we're not going to have a look at this because this is just about... in fact, we will have a look at ownership a bit later, something that's a little bit troubling about Chainlink, actually. We'll have a look at a bit of that later. But for now, we want to go into the main sort of code. So if you've used Chainlink, you would basically program against this interface. Well, at least this was the old one, and this is the new one. So new being V3. V3 is their latest version. And I did actually pull this up on GitHub here. So maybe quickly we just go through the brief architecture of how their GitHub works. So they have all their code in one repo, and you can go over here and you have all the versions. I don't know why V3 correlates to V0.8. I'm not sure why that is, but I figure, I know that. I can't actually remember why. I think it's just because they're both the latest. So I assume they were the same. Oh, no, I lie. I know why. Because over here, they have the V3 interface. So anyway, over here, we can see they have this V2, V3 interface. And this is just a combination of the old one and the new one. So we might as well just go have a look at the new one here. Sorry, here I am over here. Okay. So this V3 interface over here is the same as this one over here, kind of line for line. So, okay, let's see what happens here. You can get the decimals. Okay. You can get a description. To be honest, I've never used that function, so I don't even know if it returns a string or what. Actually, that's interesting. Maybe we can have a look at that in a bit. Exactly what that returns. Yeah, looks like it returns a string. Okay, and then you have a version. Get round data and latest round data. So what's cool about Chainlink is that it stores the entire history in the current state of the blockchain. So you don't have to access previous, or you don't have to have access to previous blocks, which can be quite difficult unless you're running your own node, to get access to historical data on Chainlink, because it stores everything, as you'll see, in a mapping, and it keeps that mapping for every single block. So you've got the entire history in the current state of the blockchain. And when you want to get, and when you want to get some historical data, then you give it an ID of the particular price point that you want, and then it's going to return you the data. So latest is pretty self-explanatory. It's getting the same data, but just the one that is, the current one, the most recent. And what comes out is exactly the same in both of these cases, right? So you get a round ID, which is literally just how they label each price feed, and it's, as we'll see, starts from 0 and counts up. So just how you would expect a counter to work. The answer is the price. Started at and updated at have to do with the way that the consensus is kind of reached, which we'll also look at more. But basically, like, when a round starts, that means that nodes are posting prices onto the blockchain, onto the smart contract. And then when a round ends, the collection of all those prices is used as the price for that entire round, and they take the median. So only certain nodes are allowed to suggest prices on these smart contracts. And at the end of the round, which automatically happens as far as I remember, but we can check into that. At the end of the round, automatically it closes, and they take the median of all those values, and that's what's going to be the answer for that particular round. So that's where these started at and updated at values come from. And answered in round is going to be the number of posts for that particular round. Cool.
Oh, and so it might change between each round.
Yeah. And it's a good point to know, because, if you only had one answer in a round, maybe you'd like to make a different decision or compared to if you had like 100 answers in a single round. Maybe you trust the data less. Yeah. I guess maybe that's what they were going for. Okay, so let's keep going a bit down here, and we have this thing. So that's the one that's implementing the interface. So the interface is what you build against, right? And then over here is the code that implements the interface. And we have this phase struct. We have the current phase. So the phase and the rounds are related. But the phase is kind of like a superset. Like the phase is like in a way, a parent of a round. But we will investigate that shortly. Let's just have a look quickly at some of the other variables that are here. The proposed aggregator and phase aggregator. Maybe I should also, so I don't know why they call it an aggregator, but you can see clearly like it's in the interface as well. So it's not even like that's hidden from the user or the contract that's going to be calling against Chainlink. I'm not sure why they call it an aggregator. Maybe because it takes a whole bunch of prices and price feeds that the nodes post, and then it's to one. I'm not sure why they.
I would imagine so.
Yeah, but basically, if you see aggregated, just replace that with Chainlink. That's what I do in my head anyway. So proposed aggregator, we can see this is another one. So inside of this proxy, which is an aggregator. So we can see it's a V2 V3 interface. right? Inside here, we have another one. So this is like aggregator exception in a way. And it can actually go on forever, technically, but we'll also see that a bit later. And here we have a mapping of aggregators, and this is actually the history. So we'll also see that in a bit. But basically, this is the history of the aggregators, and this is the current aggregator. Or proposed. I'm just gonna actually assume by the name it's actually the one that's gonna be next. But I'm not 100% sure about that. Maybe this is, and I think this is the current one, because we have a current phase, right, which is of type phase, and then inside the phase we have an aggregator. So I'm going to assume this is where the current one is stored for the particular ID, and this is the history over here.
Yeah, I would assume so too. And then I see how phases there are like parents of rounds, because the phase has an aggregator in it, and the aggregator has the round.
Yeah, well, the aggregator, yeah, exactly. So basically, the aggregator is going to have to return these. So we'll see in this proxy, let's see what happens. So the proxy implements the interface, right? So let's go, and then I guess like when you construct it, you have to give it an aggregator. Makes sense. And also we will see what these mean in a bit, but basically it's about bit shifting. So the ID and the round, so this ID over here, the phase ID and the round ID are related by bit shifts, which we'll see in a second. But yeah, let's see. Latest answer, right? I wonder if I can actually get this code to be next to me. Okay, that looks happy. Maybe we just close that, and you can also go like that and like that. Yeah, okay, cool. Now we can see the interface. Wait, this is not the interface. Is it that one? There we go. Just to help us see like what we're expecting. So the latest answer, I think this actually comes from the other. Wait, sorry. I thought I had this figured out. Let me just see where this one is coming from quickly. So the V2, V3 interface implements that one. So it's a combination of the V3 one, which we had a look at, and then this one, which I think is the older one. Oh, here we go. Okay. So it's not only does this this contract have to do the V3 stuff, but in order to be backwards compatible, it has to do the previous version, which is these. So I think lately they just condensed the entire thing to 2 functions, which return structs, as we see, so you can get all the information you want from 2 functions, latest and historical. Whereas before, you had to, in order to get like round ID, there would be a function. In order to get, sorry, not round ID. In order to get answer, there would be a function. In order to get that, there would be a function. A function. So a function for each of these. As
like
we can
they
see,
condensed it.
Yeah, it's much easier on the eyes. And yeah, I don't know why they even did this to begin with. I'm not sure. I wonder how much gas it saves. If it even saves gas, like returning this instead of a struct. Anyway, I digress. So you can see here how the V2 or the previous version has functions for each particular, or those are the events, sorry. But this has functions for each particular variable that is packed in the struct in the later version. So cool. Anyway, we can almost ignore either or, because the old interface and the current interface are basically doing the same thing, just in a different way. So whatever, let's stick with the old interface. Latest answer. Yeah.
Stream, the left screen is kind of cut off a bit.
At which point?
Just
the
numbers,
numbers,
the last bit of text.
So if I do that, can you see?
I'll check now. Sorry, the stream's a bit behind. So.
All right. I'm just wondering if it's cut off on the left of the screen, right?
Yeah.
So then if I close or open this, then it should fix the issue?
Yeah, probably. I would imagine so. Cool. Let's carry on and then see.
All right. Okay, cool. So let's see. The latest answer, which is just going to return the current price, right? Current phase dot aggregator dot latest answer. So
Okay, cool.
remember the aggregator, right? Inside, so the phase, the current phase is of type phase, and then inside there we have an aggregator, which is of the same type, right, that this contract is that we're looking at. So this contract is like, okay, cool. If you want to call latest answer, then I'm going to be a proxy, right? Proxy, and direct you towards a different aggregator, the one that is the current part of the current phase, and I'm going to get the latest answer there. So really easy. It's just a layer of indirection, right? Same here, layer of indirection. Cool. Then when we get to so you can see over here, latest timestamp and latest answer, simple because they don't have this parameter of round ID. When you want to get historical data, like get answer given some round ID, then it seems to do something a little bit more interesting. So first of all, what's interesting is that it won't throw an error. There's no revert. So you can't rely on Chainlink failing with a revert if you give it shit data. Bad data. Sorry. Excuse my language.
No worries.
It's going to return 0. So basically you would have to, it's important to know this kind of thing if you're building against Chainlink, because you might assume that given bad data, like if you give it, 10 trillion over here, or if you give it a round ID that is invalid, maybe you might expect it to fail. I mean, that's a fairly reasonable thing to do, but you can see here that it doesn't do that. And so like, even if you don't care how Chainlink works underneath, it's still important to read. I think it's a good example of like, it's still important to read the code, because you could make an assumption that is incorrect,
Absolutely.
So you have to add this layer of, if it's equal to 0, then fail on your side if that's what you want to do, So we see that over there. That's one way where that they return 0. We'll see below that there are actually more ways where they return 0 for bad data. But anyway, so this thing over here gets quite interesting. Pass IDs. So it takes this round ID and it does something to it, and we get this stuff out, right? We get a phase ID and an aggregate round ID. And we'll see soon that this is actually just doing some bit shifting. So the round ID is split. The first 64 bits are, well, we'll get there. Sorry, let me not jump ahead. And then the aggregator is the phase aggregators. Remember where we saw this, right? This is this thing over here, which I said was the history of all the aggregators ever used in the proxy. So then it's going to go grab the phase aggregator, right, using the phase ID, splitting the round ID, and you to put that into the mapping, you get the phase aggregator. And then again, if that's bad data, returns 0. Otherwise, aggregator.getAnswer. There is the layer of indirection, and it gets fed the aggregator round ID, right, which is how we do the split. So let's just have a look at that split quickly. In fact, I think it's actually over here. I think I opened it. Yeah, it's a bit easier to read it here. There you go. Okay, so let's just have a quick squiz at this. The phase offset, the phase offset we can see is 64. So that's 60. This is a bit shift, right, in Solidity. So we bit shift by 64. So that means the top half of, or the top greater than, it's a 16 bytes, 256, 16 bits. Why is, I'm getting confused. Tamara, help me. A phase offset is 64, but this is a, oh wait, round ideas. Oh, sorry, that's a 256. Sorry, it gets crossed. Sorry, I'm not concentrating very well. So you take the 256 bits, and you take so you count 64 bits up, and then you take the highest, the one above that, and that's the phase ID. And the first 64 bits is going to be the aggregator round ID, right? Because when you cast this to 64, you're basically cutting off the top. So here we cut off the bottom, here we cut off the top, and then return. Super simple, right? So you can see there that where was I? Get round data. No, it was latest timestamp answer. Here you go. So you can see over here, it takes the round ID, it splits it, and part of it is the aggregator round ID, and part of it is the phase ID. So you can see how phase is a parent here. Phase corresponds to the phase, like the contract, like the the contract that's going to be called, and then the round ID, or the aggregator round ID, is the round ID of that. And technically, you can have that be another proxy. So you could have as many proxies as you want, and you just need to change. So here puts an upper limit. This phase offset being 64 puts an upper limit on the size of the next phase offset. So you could have this guy over here, so that the aggregator be another aggregator proxy. There's literally nothing stopping that from happening, because this is an interface, you know, and this is implementing that interface, so it could totally be like that. And then you can have a phase offset of, say, 32, where the top 32 bits is the phase ID for that particular second layer proxy, and then the bottom 32 bits would be the aggregator round ID for the third layer. Don't worry, they don't do that. But I think it's interesting to point out that they could possibly do that if they wanted to. Anyway, so that's how that works. Any questions, or are we all good?
We're all good. No questions yet. Cool.
And then this is very similar. You can, I mean, it's almost like a copy paste, right? Except there's just this function that's the indirection is calling a different function. And then the latest round ID, yeah, of course. So if you want to have the latest, actually, wait, I don't know about this. Let's read this. Latest round is going to return a round ID. I wonder what it does. Okay, so you get the phase. Oh yeah, okay, so that's interesting. Add phase, what is that doing? Let's copy that. Oh, okay, bit shifting again, but in the opposite direction. Add phase, so phase.id, so you get the current phase ID, right? And then we're gonna bit shift that left. Oh, okay, that's very cool. So the original ID is taken from the aggregate. So basically what this is saying is, if you call latest round ID, you get a round ID that you could feed into these functions, and it would come out correct. So here, sorry, I don't know if I just jumped ahead there. Did we all understand what happens here?
Yeah, I think so.
Should I go? Okay, cool. Basically just taking, you know, a 16-bit number, then bit shifting that to the right by the phase offset, and then ORing that with, so bitwise ORing that with the original ID, which we can see gets taken from this layer of indirection. So it gets taken from the aggregator below that. So this like reconstructs the phase ID that you can feed back into these functions, where we just saw it getting taken apart in this function pass IDs. Cool. All right, so that's looking good. This is kind of similar. Oh, so this is from V3, right? Get round data. Here you go. So over here, it's doing exactly the same thing, except it's just going to be grabbing. Yeah, so it takes all of that stuff. Why does it say add phase IDs? Interesting. I'm wondering if it's worth looking into that. So it splits it, and then, oh, I guess that makes sense. Okay, yeah. No, of course that makes sense, because over here we saw it has to recombine, or it has to create the phase ID, but doing bit shifting and whatever. And over here it's giving the round ID, so it has to do the same thing as what it was doing here, except this add phase and add phase IDs, they're going to be slightly different functions, but I'm pretty sure they're going to be doing the same thing. Add phase IDs. Yeah, look, even in add phase IDs, you can see it calls add phase. So it's doing the same thing. It just has to work a bit more because it's got to return a struct, etc., but it's doing the same thing. So that's fine over there. Latest round data. This is from V3, right? So we have this latest round data over here, and that is doing, yeah, that's just giving the latest, but in struct form. Cool. Propose get round data. Where are you from? Huh. Okay. So now we're getting to has proposal. That's interesting. Okay. We are getting to the section now where we're not on the user side interface anymore. So we're oh yeah, I forgot to say. So let me say something nice and irritating about this whole setup. Right. While I was hunting through this code, I realized like, oh, I can just look on GitHub. That's like so much easier to read because I can pull the entire repo and then use my own personal setup to go through the code instead of using browsers like a caveman. But then I noticed that this code is not the same as this code. And so that's why you should really never just blindly trust what you see on GitHub. Go actually have a look in the intently or at the code on the blockchain. Because even here, even with like the line, the starting line is different. It kind of looks the same. Okay, aggregate a V2 interface, aggregate a proxy interface. So we can go hunt down what that is. Maybe that is actually just this. Who knows? Maybe confirmed owner is actually just own. I don't know. But they're not the same. So what is deployed here is not the same here. Otherwise, that text would have been exactly the same. Like there's no trickery happening with deployment here where like where hard hat or forge or whatever is like changing this stuff because it's optimized. No, there's none of that. That should be exactly the same if they were exactly the same deployment, and they're not, which is interesting. But yeah, I don't think there's many differences, at least not in this particular contract. There ends up being differences with other ones, as far as I remember. I think we might see later, but there ends up being differences a bit later. Anyway, let's get down to this thing. Aggregator interface. Sorry, what am I doing here? This one is owned. Oh, wait. Okay. So there is actually no interface for this other function that we just saw. This, what was it? Propose. Propose get round data. So this is not part of an interface. And I guess that makes sense from the user's perspective because the user should not be able to call this function. And so this should be a modifier that at least promises that or enforces that. Oopsie, did I? Oh, man, I'm sorry.
No worries. It will be a modifier that ensures that, I'm sure.
Yeah, let's not make any assumptions though. But I'm also sure. Let's go have a look at the actual code and see what happens. Hello. There you go. Require proposed aggregator not equal to 0. So that's interesting. The proposed aggregator, remember, is the second layer. Well, actually, I'm just assuming that. I'm pretty sure that's what that is. No proposed aggregator present. Has proposal. Interesting. Let's follow this around. Okay, so that did not do what I expected it to do. Propose get round data. Sorry, that's not the one we were looking at. Now we've got check access there. That I mean, surely we don't have to look at that.
Yeah, we were also thinking of has proposal, I think, not check access. But check access will ensure probably that it's not a user.
But also, where am I? I'm now lost. Oh, here. Propose get around data, or were we? Yeah, we were here. Okay, let's try and remember that. 353, so I don't have to scroll too confusingly later. So has proposal checks if this variable up here. Oh, you know what? I'm going to see if I can find this on GitHub. Let's see. Has proposed aggregator should be at the top here, just so we. Here we go. So line 18 over there. It's a different name, but whatever. So that variable has to be, which is private, has to be. I wonder if it's private here as well. Just go check that quickly. No, it's public. That's a difference. There you go. I mean, it's not much of a difference, but like still.
Yeah, it's not a huge difference when you're working with blockchain stuff, but still, it's hectic that it's so different.
Yeah, it's super irritating when you're trying to get this information because you can read that. It's public on the blockchain, but like I think Etherscan or some, I don't know if it's Etherscan or someone else, but they don't allow you to read that. It is readable, but like, yeah, it becomes a little bit irritating. You can't interact with it in a contract, but technically you should be able to read it as a person just viewing the blockchain.
Yes,
and I think some of the websites, some of this scanners don't allow you to do that, which is kind of irritating. Anyway, go back here.
Unless today I saw a way of using Web3.js, and you can get those private to read them, those private variables, but that's not really a Solidity.
Nice. Yeah, that would be cool. But again, it's like I have to go write code now to review this thing. It's a bit of a mission. Okay, proposed get round data. So this is gonna, okay, it's a view function, whatever, and it's just gonna return the proposed aggregator dot get round data. Cool. So now we see that there's this idea of an aggregator that's going to, I guess, be scrutinized. You know, it gets proposed and then scrutinized by the rest of the DAO or the nodes in the system, and then it gets accepted. So here we're just reading, right? We're just reading the stuff from the proposed aggregator. Let's actually go see where this gets set. So I'm just going to have a look in GitHub because I'm just, hopefully it's the same. So that's just a read function. There we go. Okay, propose aggregator, and only the owner can do this. We should also go have a look at what this is exactly. Only owner. Who is that? I wonder if you think it's interesting. Actually, I'll pose the question: who owns Chainlink? Who owns Chainlink? Is it a DAO? Who owns all this stuff? If we go,
I would hope it's a DAO because it's a decentralized organization.
It's also the biggest supplier of price data in the whole of DeFi. Well, as far as I know, I don't. I'm pretty sure about that, but I'm not 100% sure. Anyway, I'd love to know if anybody has guesses on this, and then we'll come to this later. Also, oh damn, I've been blabbering away way too much. We only have 15 minutes left, right?
Yeah, just over.
Oh, okay. Let me try to get through. Maybe it's not super important then that we go through this. Basically, the aggregator is, you know, something that can change. As we saw, there's the historical set of aggregators, and there's a current one and a proposed one, and then the proposed ones are only allowed to be proposed by the owner and confirmed by the owner. And set aggregator. I'm wondering why they even have that. Why even propose and confirm if it's just the owner who can do this and there's no requirements otherwise? So the cool. Oh, I guess, yeah. Okay, interesting. And then it deletes this. So, you know, you have to propose first because of this line in order to have it work. Why? Yeah, there's no requirement. So you can basically just follow one transaction with the other, propose, confirm. I don't know what the point of this is, to be honest. That's very strange. I'd love to know anyone's thoughts if they have an idea of why that is. Okay, cool. So we've basically gotten to the end of that contract. Okay. Set aggregator. Wait, what? This doesn't have a set aggregator here. Wait, maybe it's just the same as the other one, confirm aggregator. Oh, that's an internal function. So it's just going to be a helper, add phase, pass IDs, add IDs, help proposal. Yeah, now we're at the end of the contract over here. Cool. So let's actually just move on because there's a couple other interesting things and I want to just get through those. Let me just look at my notes. So the reason why I was actually having a look at this is because we want to do don't hate me or tell me I'm an idiot because I know this is going to sound crazy. We wanted to do a linear search in a smart contract through the round IDs on Chainlink.
Okay, I'm not going to tell you that.
Yeah, don't tell me. Basically, because of this get round data, right, that does the bit shifting, whatever, you know, it does the bit shifting, we went through it. Because of that, we weren't quite sure, and because of the fact that you call the proxy, right, the proxy is what you call, you can go call the phase aggregator yourself, you know, you can literally go, let's actually grab this, and let's go on to Etherscan, and let's go have a look at, let's go read the contract and go find this actual phase aggregator. where are you? Phase aggregators. Oh, that's going to be the whole thing. Where's current? Would be great if they, no, they do order this by, where's current? Oh, don't tell me it's private. You see what I mean? Okay, let's actually, this is something that's super irritating. No, private. Current phase is private, so Etherscan is not going to allow me to look at it. Trash. I can't believe that. Anyway, that's just something so irritating, but whatever. I guess I could just pick a random phase ID and then just go for it. What is it accepting here? Yeah, it does that whole bit shift thing. So let's go propose. Sorry, so there's no proposal at the moment. Cool, that makes sense. Phase aggregators. Goodness, let's just try one. One should be. There we go. So we can go to that contract address, which you can see is different from the current contract. And we can also go have a look at the code there in Tenderly. I don't want to do too much of this, but I just want to show that you can actually just go call this contract straight. But it's not the best idea because of the fact that whoa, I have been logged in already. Okay. You can actually go have a look at the base layer like aggregator, but it's not a good idea because they might stop that aggregator. It might stop being posted to. So you really are at the mercy of Chainlink. If they just stop posting data, you have to defend against that because it's a possibility, right? The data is only there once, or as much as the people want to keep putting the data there. But it's totally possible that a data feed turns off. And that's exactly how they do upgrades, right? So this contract we were just reading through is a proxy that allows for upgrades, but also keeps history, you know? So we can have a look here. This is going to be exactly this. Although it doesn't look the same. Oh, it's just a bunch of math. More. I should say arithmetic, actually. It's just arithmetic. Here we go. But you can see again, this is like the same type of stuff. You see, it looks the same. It implements the same thing, but it's not a proxy anymore. It's this, I don't know why, Flux aggregator. I actually really wanted to get into all of this, but we definitely don't have time for that. They do a lot of very interesting Solidity stuff in here, which I really admire, actually. It's really cool.
That
Yeah,
could be
it's
a
like
cool
really...
part too. Let's see.
Yeah, I would also very much recommend going to have a read at this because there's just some super legit Solidity in here. It's like, damn, I wish I could write like that. It's like, nah, you know, next time I write like Chainlink does. So as much as I poo-poo them about certain things, at least they, you know, write good Solidity. So, you know, we can see that you can also go call this contract because I'm not going to go find the functions, but you can see it implements the interface that you build against, so you can go call that, but it's better, at least recommended by Chainlink, to rather call the proxy, you know. But if you really wanted to, you could go call that one. And so the round ID does not always increase by one, right? Let me actually show that. The round answer, round ID. Where are you? Hello. Let's actually just search like this. Okay. Round ID equal to, you're gonna know. Oh, you can't even find round ID. Round ID. They obviously call it something different here. Oh, get round data. Look, it says round ID. Oh, sorry, that's interface. Aggregator. Come on. Actually, just do this quickly and make it easier. Okay, data's answer. Rounds. There. Okay, update round answer. Oh wait, I just forgot what I was looking for. What was I looking for again? Sorry. Oh, I wanted to show how the round ID gets updated.
Yeah, it's not
incrementing. Yeah. I just want to show that there's that plus. So latest is equal to round ID with update round answer, and it gets. Oh, this is internal. So let's go have a look at this guy. Hello. Round ID here. Submit. Oh, this is going to also check valid oracle round. Okay, so you can submit to any round. Let's see, valid oracle round. Where's this defined? Here we go. I think. Round ID not equal to that. Round ID not equal to 1. Yeah, here we go. So this will be where it checks. So this makes sure that the round IDs increase in this smart contract by 1 each time. But we just saw that the round ID in the proxy contract is split. The first 64 bits are the round ID in the base contract, and then the top 64 bits are the phase ID. So you can't assume that. And also, I'm not going to try to find it right now. There's not enough time. But you can also see that the round ID is set to 0 at contract creation or initialization. So you know that the round ID starts at 0 and increases by 1 in the base contract. But if they update, so if the proxy updates to a new base contract, then the phase ID is going to increase by 1, and then which is going to be the top after 64 bits, you know, like 256 minus 64, which I'm not going to try to do in my head right now. But that many bits is going to be the phase ID increases by 1, and then the bottom 64 bits get set to 0. So you can't actually assume that the round ID increases by 1 always. So if you're searching linearly backwards, you might not get good data. And the only way you're going to know if you get good data is if you check if it's equal to 0. Remember, because Chainlink is not going to revert if you give it a bogus round ID. It's just going to return 0.
0.
Yeah, and I guess we just hope that no prices ever go to 0.
Oh yeah, because then
exactly. Then you wouldn't know the difference. Is it a bad price or is it bad data? Oh, yeah, exactly. So there's one last thing I want to do. Oh man, I thought hour goes so quickly here.
These episodes are always so short.
Yeah, I think I just talked too much cack.
There's also so many interesting details though.
There is, right? Yeah, and I just want to do this last thing, this last little bit. Where did did anybody have a guess, by the way, at who owns Chainlink?
No one did in the chat, but I got load shedding, so I lost that screen for a bit, so I might have lost a few messages in chat.
All right, okay, let's go have a
Who owns Chainlink?
Yeah, here's the owner, right here. So remember, this is the same contract we were just looking at, the 728. Yes. Here's the owner. Let's see what the owner is. It's a contract, right? Reader's proxy. Well, okay, so I know what a Gnosis safe looks like because I've dealt with them before. But this is a Gnosis safe. Here are the owners, right? How many owners are there? Approved domains. Nonsense. Anyway, there are 7 of them, and where's this? See, there it says. Gnosis safe. Great, you got that there. Yeah. So it's owned by a Gnosis safe, right? Not a DAO. Well, unless all of these are DAO, but who sets up a Gnosis safe and then has multiple DAOs? Like, no. This is going to be.
That's a nice way to replace governments. A Gnosis safe of DAOs, but each DAO is a government.
Yeah. But I'm fairly sure.
So 7 people own all the data on all the blockchain.
Let's go have a look here. Yeah, let's go have a look here. And I wonder how many. I didn't go having a look at like how many of the smart contract Chainlink smart contracts are owned by, the same people. But check this. There's like no transactions. What is this even? It's not a contract. It's just an externally owned account. I don't know what that is. This too. So what is that? Those look like fake accounts to me. They have no transactions. So they're the owner of Chainlink, but they have no transactions. That just looks like a bunch of rubbish to me, to be honest. Looks like, randomly created accounts. And that's a bit worrying, seeing as this is like the biggest data provider in DeFi. So 2 out of the 7, I think you need 4. So I worked it out, you need 4 out of 7 signatures for that particular Gnosis safe in order for. Yeah, so 4 out of 5, right? And who knows who owns these other ones? So at least this looks like it's used, right? So look, approve hash, execute. Yeah, I mean, it's going to take too long to try and investigate too much of this, but at least that address looks kind of real. This address also looks kind of real, and so does this one as well.
I'd love to see a
Right.
analytics board on one of these addresses.
Yeah, right. Yeah. And let's also just have a squiz at what this owner can do. So how in trouble are you if Chainlink just decides, oh, sorry, we're just going to turn off all our data feeds? Let's see. So the owned contract has this only owner, I think. Is it? Yeah. Okay. Let's have a look here. Only owner. Propose aggregator. So they could propose a brand new, they can upgrade the contracts. That's huge, right? They have to upgrade it to a V3, V2 interface. So they can only upgrade it to another one of those, but you don't know what kind of code can be put in there, right? Confirm. So it's funny. They propose and confirm. I mean, we just had a look at this, right? It's weird that that has to be done because only the owner can do both of them. And there's no requirement about consensus, as we can see. There's no requirement. Unless there's something in here. Let's have a look here quickly. No, there's nothing in there. So let's keep having a look at the power. Set controller. Access control. So seems like the owner can also is able to change the owner, or is able to change the contract that has the code for changing the owner. Okay, that's about it. But that's quite a lot of power. And it all belongs
especially for an oracle, and an oracle like we said, the biggest oracle. But there are other oracles popping up, like UMA and API 3.
Yeah, and Maker's made their one
public. Yeah, they made their one public, which is awesome. And Maker will definitely be a DAO. I mean, they make a DAO.
Yeah.
So
well, we say definitely, but it would be worthwhile looking at who owns their contracts.
We've learned a lot today.
Yeah, exactly. I think we're pretty much. I mean, okay, so we're now at the end of the topic, and I think we're also out of time.
We are.
Maybe we just stop there.
Yeah, thanks. Thank you so much for joining, Stent, and thank you for watching another episode of Solidity Fridays. We will see you next Friday.
Cool. Peace out.